when we got left off, we created our cube to rotate. And now we're going to add our movement to our character. And we do that by going to our script, and let's go to getting started. And here we can also be a little fancy, and we can actually add a change in speed. Now, I like the rotation of the basic 0 to 1 on our joystick or our keyboard, so that's fine, but you can always add speed by doing this, multiplying our axes by speed. Now it's going to be really fast unless we multiply it by the time it took, by the fraction of the time it took to update a frame, or in fixed update, the fixed frame rate. So times speed, or times time dot delta time. See? The time, last frame rate, yada yada. So if we hit save, now it's going to be smooth. Time and delta time, what you have to know about it is that it makes things smooth, because that's like time, right? So now when we rotate, it's a lot slower, but time dot delta time, right? So pretty cool stuff. Again, I'm just going to leave it at this, because that was fine for me. So let's get started with our velocity, shall we? In our fixed update, we're going to hit enter over here, and we're going to do our target velocity. So how fast are we moving or wanting to move? So we're going to do vector 3. And vector 3 deals with, in Unity, our movement here. So we have, this is our vector 3, which we have y, x, and z. And corresponding in our code, we need to specify x, y, and z. So our target velocity is definitely going to be a vector 3, and which means it has x, y, and z, and we're going to call it our target velocity, right? So target velocity equals, now what does it equal? You kind of want to put x, y, and z, but code cannot be that simple. It actually has to equal another vector 3 with the input, and it can't equal any random vector 3 because this is C#, which every vector 3 that you call requires this lovely word called new. And in the new, you have a vector 3. It already suggests it for you. It says, hey, are you looking to create a new vector 3? Yes, you are. And in there, now, open parenthesis, close parenthesis happens automatically. It might not. So remember, at the end of this, put a close parenthesis. We need an x, and we're not moving on the x because we're rotating, all right? We're not going to go up and down on the x. That's pointless. We're not moving on the y because, again, we're not moving right to left. We're not moving up and down. We are moving forward. And forward means what? Means the up and down arrow key, the WS key, or if we go into our input manager, so project settings, input manager, we see vertical, and voila, it is right there. And I promise I won't make a spelling error this time. So in here, we're going to do input dot get axes, and you already know it goes here, but I'm going to just, vertical has to be spelled out correctly. And remember, if you change the name in the input settings, you will have to change the name here. So I suggest you don't for this tutorial series. And at the end, we have our brackets, everything's matching up, we hit a semicolon, and bam. Now that's our target velocity. Let's do something more creative and more interesting, and make sure that our target velocity is relative to our world position. And the reason we do that is to make sure that when our object is going forward, we are also going forward and not relative to the world. So to do that, we want to do target target equals player transform, because it's relative to the player. Okay, and now we want to grab the direction of the player, right? So transform. Even if you start spelling direction, you can read this transform A, right, or transform direction from local space to world space. So actually we're grabbing the world space to ensure that it is always on the z-axis relative to the player. And this is just a double check. It shouldn't harm if you don't include this, but this will ensure that no matter where the player is going, it's always doing this. It's always grabbing the z. And so let's go back here. And in this, here we go target velocity, so relative to the target velocity. Now we want to add some speed to it, because this output is 0 to 1, and on joystick it'll increase, 0, 0.1, 0.2, 0.3, whatever, or 1. And now we're going to multiply it times our speed to make it 1 actually equal our speed. So to do that, we go target velocity equals. And if we do 10, would that work? No, it won't, because we can't, first of all, we can't make a float. We can't make a woman go into a man's bathroom. We can't make a float go into a vector bathroom, because it requires 3 inputs, right? So first of all, we have to multiply it. So it multiplies every point. So x will be multiplied times 10. Y will be multiplied times 10, x will be multiplied times 10. And to do that, we're going to make it equal to the, we're going to do this. I'm going to show you, and I'm going to write it out before I confuse myself. And I know that I'm starting to get a little confusing, so I'm going to just do this. And you can figure out that I'm just multiplying this and setting it back to this. And now, whatever this is this times 10. Now, after that, we can go in and start adding a little bit of velocity to apply force. And we're going to make sure it doesn't exceed. So, the reason why we do that is if we did this, rigid body, and please don't, you don't have to follow me along, because this is going to come out with something really fancy. We're going to add some force, rigid body, add force. We're adding force. And what force are we adding? We're doing transform velocity. Or target velocity, sorry. Like so. We hit save. Again, don't have to follow me along. And we hit play. When I hit forward, I keep on going faster and faster and faster, and bam, like an airplane. And we don't want that. We just want to stick at a constant speed. And to make that happen, we're going to need to do a couple of math functions, actually, to make sure that we're not going to fly off the face of the earth. And we can start that right now by doing a vector 3, and we're going to grab our current velocity. How fast are we currently going? And we're going to call this underscore velocity equals our rigid body velocity. Right? And to show you how that works, again, don't have to follow me. If I debug it, so I print velocity. Save. Now we go into Unity, and I open my console here, and I collapse it so it not, get some like tantrum. If I keep on going forward, I'm not going forward. I definitely deleted velocity. Let's quickly add that back. So I'm just going to go back. This is just, again, for demonstration purposes, to show you how things work. So with that being added, bam. Again, I'll erase this before the next video, but to show you that it is true, we're increasing past our speed here, and we're continuously going to just fly off to space. And we're going to prevent that on our next tutorial video. So see us in part 8, where we bring down some rules to our velocity.